In this lab, we will be doing the decomposition of hydrogen peroxide and making a kinetic study, where chemical kinetics deals with the experimental determination of reaction rates from which rate laws and rate constants can be devised. Decomposition of hydrogen peroxide in aqueous solution proceeds very slowly. A bottle of 3% hydrogen peroxide sitting on a grocery store shelf is stable for a long period of time. This decomposition is shown by the equation on the screen. A number of catalysts can be used to speed up this reaction, including potassium iodide, manganese fluoride, and an enzyme catalyst. If we conducted the catalyzed decomposition of hydrogen peroxide in a closed vessel, we are going to be able to determine the reaction rate as a function of the pressure increase in the vessel that is caused by the production of the oxygen gas. If we vary the initial molar concentrations of hydrogen peroxide solution, the rate law for the reaction can also be determined. Finally, by conducting the reaction at a different temperature, the energy of activation can be calculated. So our objectives for today's lab will be to conduct the catalyzed decomposition of hydrogen peroxide under various conditions, to calculate the rate constant for the reaction, to determine the rate law expression for the reaction, and to calculate the energy of activation in it for the reaction. In our pre-lab quiz, you calculated the molarity of a 3% solution of hydrogen peroxide and a 1.5% solution of hydrogen peroxide. You will need those values recorded on the table below. Part 1 of our procedure, we will decompose our 3% hydrogen peroxide solution with a 0.5 molar potassium iodide solution at room temperature. We're going to prepare the reagents and then ensure that they're all at the same temperature. Obtain room temperature water to set up a water bath to completely immerse the test tube. Use a thermometer probe to measure the temperature of the bath, or you can use a thermometer to measure the temperature of the bath. Record this temperature in your data table for parts 1, 2, and 3 of the lab. Presume that the water bath temperature remains constant throughout the reaction. Then measure out exactly 4 milliliters of 3% hydrogen peroxide solution into a test tube. Seal the test tube with a solid rubber stopper and place the test tube in the water bath. Measure exactly 2 milliliters of 0.5 molar potassium iodide solution in a graduated cylinder. Draw about 1 milliliter of potassium iodide solution into a Berol pipette. Invert the pipette and immerse the reservoir end of the pipette in the water bath. Connect the gas pressure sensor to channel 1 of the vernier computer interface. Use the plastic tubing to connect the one-hole rubber stopper to the gas pressure sensor as shown on this figure. Start the Logger Pro program, Experiment 12, peroxide, then remove the test tube from the water bath and remove the solid stopper. Remove the plastic Berol pipette from the water bath and quickly transfer the 1 milliliter potassium iodide into the test tube. Tap or lightly shake the test tube to mix the reagents. Seal the test tube with the one-hole stopper connected to the gas pressure sensor. Place the test tube back into the water bath. Click Collect to begin data collection. Data will be gathered for about 3 minutes. If necessary, I recommend we do this, gently hold the test tube so that it stays completely immersed in the water bath. When the data collection is complete, carefully remove the stopper from the test tube to relieve the pressure. Dispose of the contents as directed by your instructor. Examine the graph of part 1. Select a linear region just beyond the initial flat portion of the graph that covers 1 minute of the reaction. Click the linear regression button to calculate the best fit line equation. Record the slope as the initial rate of the reaction in your data table. Store the results from this first trial by choosing Store Latest Run from the Experiment menu. Then rinse and clean the test tube for a second trial. In our second trial, we will be decomposing a 3% hydrogen peroxide solution with 0.25 molar potassium iodide at room temperature. We will measure out exactly 4 milliliters of 3% hydrogen peroxide solution in the test tube, as we did before. Seal the test tube with the solid rubber stopper and place the test tube in the water bath. Add 1 milliliter of distilled water to the remaining 1 milliliter of potassium iodide solution in the graduated cylinder. Swirl the mixture gently to mix. And then you draw 1 milliliter of this new potassium iodide solution into a plastic barrel pipette. Invert the pipette and immerse the reservoir end of the pipette in the water bath. Allow both the test tube and the barrel pipette to remain in the water bath for at least 2 minutes for proceeding. And then we will collect data and analyze our data as we did in the previous part 1. Then for part 3 of our lab, we will decompose 1.5% hydrogen peroxide with 0.5 molar potassium iodide at room temperature. We're going to prepare a 1.5% hydrogen peroxide solution by mixing 2 milliliters of distilled water with 2 milliliters of 3% hydrogen peroxide. Transfer the resulting 4 milliliters of the 1.5% hydrogen peroxide solution to the test tube. Seal the test tube with a solid rubber stopper and place it in the water bath. Rinse and clean the graduated cylinder that you have used already for the potassium iodide solution. Add a fresh batch of 2 milliliters of 0.5 molar potassium iodide solution to the graduated cylinder. Draw 1 milliliter of the potassium iodide solution into a plastic barrel pipette. Invert the pipette and immerse the reservoir end of the pipette in the water bath. Allow both the test tube and the barrel pipette to remain in the water bath for at least 2 minutes before proceeding. And then collect data, store the data, and analyze as we did in the last part of part 1. And then finally for part 4, we would be decomposing a 3% hydrogen peroxide solution with 0.5 molar potassium iodide solution at around 30 degrees Celsius. Conduct part 4 of this lab as you did in part 1, with the only exception that you'll be using a water bath temperature of about 30 degrees. You can use this by heating water or getting some hot water from the tap. Once you've completed part 4 of the lab, you're ready to begin your data analysis. Record your calculated initial concentrations, which are corrected for mixing. Record the slope as the initial rate of the reaction in your data table. Store the results from the first trial by choosing Store Latest Run from the Experiment menu. And then determine the orders of reaction with respect to hydrogen peroxide and iodide ion. Then you can calculate the rate constant. For example, on this slide we have some sample data, and it shows the decomposition reaction of hydrogen peroxide. We know that our rate law is equal to a rate constant K times the hydrogen peroxide concentration raised to the power of X and the iodide ion concentration raised to the power of Y. And then on the table at the bottom of this slide, we have 3 sets of experimental data. If we look at step 1 and 2, we can see that the main difference here is that we've doubled the concentration of iodide ion. When we double the concentration of iodide ion, we have also doubled the rate of the reaction. Therefore, Y is equal to 1. And then when we use trials 1 and 3, we can see that we've doubled the hydrogen peroxide concentration, and the rate goes up by a factor of 4. Therefore, X is equal to 2. And then on our last frame, it shows a graph of 2 of our experiments with the regression analysis of the data that we've obtained.